Okay, for this first one, what you have to notice, it starts out for every real number. So that means we start out with the universal quantifier x for every x or real number. And now look at these properties. It's going to be greater than 0 whenever it's the square of another number. So think back to what we did in the very first chapter with conditionals. That whenever means that the second part is going to start the conditional. So it's whenever x is the square of another real number. So x is going to be equal to y squared, where y is a real number. That implies this part, that x is going to be greater than 0. And the second one, you just have to remember what all the symbols mean. So we're starting out with there exists an n. Okay, now a few questions were asked about uniqueness because I mentioned unique and unique right there. And remember that unique is the existential quantifier with an exclamation point, which is not what we have here. We just have there exists a natural number m that satisfies these properties. N is bigger than 100 and its square is even. So that means the answer has to be this one. Okay, so this is false. We just have to find some counterexamples. 0 squared is not greater than 0. Here's another one. 1/2 squared is not greater than 1/2. So this is false. And for the last one, here's the issue right here. Yeah, the integers are the natural numbers are a subset of the integers. And the integers are a subset of the real numbers, but the proper way to write that last subset would be the rationals are a subset of the real numbers. So if you want to write this string of subsets properly, you would have the natural numbers are a subset of the integers, are a subset of the rational numbers, are a subset of the real numbers. So that one is false.